Hello and welcome. I'm Bonnie Libhart. You're watching Vision Plus, a vision for the world. What's going on in the world? One of the things that's going on is that we're in space, and that is an exciting thing. And there's also a project that you may be interested in finding out about. Dr. Jeff Cerny is with me today, and Dr. Cerny, who is the Supervisor General Engineer. Now, you may have to correct me, Dr. Cerny.
Okay.
And the Unmanned Ground Vehicle Office here in Huntsville. And you have a project coming up that is about, that you're going to be working with the middle school and Hazel Green. Welcome to Vision Plus.
Thank you. Good to be here.
Tell us a little bit about the project. I think we're going to get to see a videotape clip, but tell us a little bit, introduce the clip.
Well, what we're doing, I'm on post out in the Arsenal as a Deputy PM for Unmanned Ground Vehicles, and what we're doing is looking at how do we expand the knowledge of that technology in the local area. I also am president of a local chapter for unmanned vehicle systems, and as a result of that, we are trying to put an educational project together here. As a result of that, we're looking at having built a robot from a Heath kit that the government has, and we want to offer that up to the local industry set and educational set. We wanted to have some science, computer science, control technology available. With that thought in mind, we went to a couple of local schools and talked to them, would they be interested in doing a robot challenge competition. And the information we got back is that 2 of the schools were interested, so we said we want to do this as a pilot case, try it as a test set, and see how it would go. The 2 schools that we've talked to and they've consented to do the test is Hazel Green here in the local area and Challenger Middle School in the Huntsville area. And basically we'll run a competition between the 2 schools where we have them take a robot, program it, have it go through different tasks and functions in a room, and then we will judge them on certain criteria, functional criteria, like how many lines of programming, how well did it, how fast did it do it, and how creative were they in doing that. And as a result of that, then we will award a monetary fee to the winning school, which we're looking right now in the neighborhood somewhere around $1,000 to go to the winning school, and with no restrictions, that the children can determine how they want to spend that funding, if they want to give it to the school, to the library, or if they all want to go out and buy more computer software, we'll let them do that. We're also talking with Apple Computer, and we're looking at potentially having a computer donated to the school that wins as well. All right. Now, you had CNN actually covered a project like this in Georgia. CNN covered this project in Atlanta, Georgia, for the Association for Unmanned Vehicle Systems. They sponsored a college-level competition, and that competition went out nationally, and they had 5 schools come in and compete on the competition. And in this case, it was an unmanned air vehicle competition. And
this one is ground.
And this one will be ground here in the local area. It was conducted at the Georgia Tech campus. They had the students come in. I attended the reception along with some of the other people from the association and the local campus. They conducted the competition. We'll see from the clip it went pretty well. From the clip, the main thing was the enthusiasm from the students.
I can imagine them just getting really wild.
Right.
I think they can be involved.
The enthusiasm from that. And it looks like we're going to continue to next year with that. That effort looks like it's going to be expanded to international effort. And we'll probably have international students coming in to compete with that.
Wonderful. Well, let's go to that clip right now. CNN.
Play volleyball on this court. But instead, they played with robots. The Association for Unmanned Vehicle Systems turned the court into an arena for robots designed to fly. Engineering and science students from 5 universities entered their computerized projects, hoping to demonstrate good science and to win a $10,000 prize.
This is a way to get students interested in unmanned systems and to be able to apply what they're learning in schools.
The rules called for universities and industry to cooperate in creation and design. The results amount to off-the-shelf technology and some wishful thinking.
A lot of people doubted we could even make it this far, so this is a big accomplishment for us. We're not really competing against the other teams, we're competing against ourselves.
But all the competitors faced a tough challenge. That is, robots must retrieve 6 orange discs from a round ring, carry each of them over a wall, and drop them into another ring. And each robot must be autonomous, able to function on its own without any human help. Guidance systems relied on either lasers or ultrasound.
So they got 1, 2, 3, 4, and they'll send out an ultrasound signal. What we use that signal to correlate our position on the arena. It gives us an XY coordinate.
The UT Arlington robot packs microchip sensors that are programmed to recognize the orange disc and a magnet to pick each one up. They called their entry the right half plane. Right half plane is an engineering term for something out of control. California Polytech had trouble controlling its hovercraft. It got to the ring, picked up the disc, but the technology demonstrated here may appear crude and unworkable, yet a similar type of flying unmanned vehicle has already proven itself in the war in the Gulf. These images were relayed by Pioneer, a flying robot that helped pinpoint Iraqi bombing targets. In this case, the Pioneer was controlled by radio from sailors on a battleship. But designers think future autonomous robots could help spot forest fires or hunt for leaks along oil pipelines.
You're working on something that you know that there's going to be a solution in the next 25 years, and you're wondering whether maybe something that you come up with will be the kinds of solutions that people will use in the future.
But from here, the future seemed far away. All 5 schools wound up sharing the prize money because nobody could get their robots to work as planned. For now, some Georgia Tech students proved people can still outdo robots.
That was a clip from Dr. Jeff from CNN, brought to us here by Dr. Jeff Cerny. Dr. Cerny, that was interesting how they finally accomplished their goal. They took the unmanned vehicle person and picked it up and dropped it over. Well, tell me what's the result of the project?
Of that particular project, the ultimate result is to get engineering students interested in unmanned vehicle systems. The actual project is to take those discs and move them over to the other side, and the school that accomplishes that task will receive the prize of $10,000.
And in that particular case, since no one won, so they split the $10,000 between the 5 schools.
Between the 5 schools.
Mm-hmm. Well, they were excited, and I bet they do it. They said they were going to do it this year, next
They
year.
were real excited. They came in on a Friday, and the competition was on Monday, and they were working till 2 or 3 in the morning trying to get their machines working.
You know, they actually did get them to lift off the ground and do some of these things that they wanted them to do. It's just then getting them to actually pick the disc up. That didn't look like an easy project anyway.
No, but I think they've learned, and also the other thing was that they learned that the engineering students need to work together as a team in a project, and I think that's what real life's all about as well.
That's true, that's true. Now, here in the Tennessee Valley, or in the NASA in Huntsville, your project is for unmanned vehicle, ground vehicle.
For ground systems.
Now, how is that different?
We're mainly trying to do teleoperation and autonomous operations.
Now, break that down. You're a daddy with 4 kids under 10 years old and under, so you explain things to me for your children.
It's for remote operations, which is similar to what...
remote control car.
Remote control cars.
Okay.
That would be teleoperation, would be remote control cars. Autonomous would be having something, tell it to do something, and it goes and does it on its own. No one interferes with it until it accomplishes its mission.
Now, when you say tell it, are you saying voice?
You give it a command, computer command.
Oh, computer
command. And what we're talking about here, and what we want to do is...
it's probably a little hand computer rather than sitting at the desk away from the project.
For the science projects here that we're talking about, we're probably going to be using a desktop computer to program it, and then the computer commands will be transmitted by radio frequency down to the robot.
Isn't that exciting? Oh my! What a job! You should just be smiling to be a scientist involved in that.
Well, I think I'm more excited about hopefully instilling in the children that are coming up today the interest and the excitement about science. And more specifically, in this case, hands-on science. It's not out of the textbook, out of the manual, that they're actually going to get involved in programming it and do things that you actually do in the real world, working as teams, resolving conflicts, and learning how to actually use science to do some benefit to them. In this case, hopefully we think the prize is enough that they think it's a benefit for them. And at this age that we're talking about, middle school, we hope
They're
that
like what ages?
well, one of the schools will be 7th and 8th graders, which is Challenger, and then Hazel Green will be 9th graders. This is a pilot test in the Tennessee Valley. We're trying to see if we're trying to learn from the association, is this important at this level? Can they do this task? And then we also want to, if we can do it, then we want to expand that to all the schools in the Tennessee Valley and have a competition there and install the computer science programming excitement within the schools, which I think in the recent press that's come out, the president is talking about, you know, that we are behind in science and math. And I think that's because maybe some of the kids aren't as excited or brought into that. And I think maybe this might get them excited at an early enough age that they can get dedicated to that, so when they go to college they're prepared to get into the science and math.
You said a little key thing that as a mother and grandmother I get excited about. It's a teamwork effort that they learn that. It doesn't have to be that you got to be a jock that plays football or basketball or something, that you can also learn that teamwork as a result of these science projects, and that is so exciting.
Right.
Now your children, you have 4 children, and they're not currently, tell me about them just for a moment. They're in homeschooling.
We're homeschooling at present. We did that when we were up in Virginia, and we're now homeschooling again, teaching them the skills and traits that we think they need.
Of course, they're the younger. They're not the middle-aged.
No, they're not middle-aged. But my oldest daughter wants to come to all the meetings and actually says, is it my turn now to program the computer and program the robots? So she's excited about that. So hopefully some of that wears off on her as well.
Now, what ages do you think youngsters can get interested in computers? And
I think a few years ago it would have been an older age set, but as the computers, and more specifically as software becomes easier and more user-friendly, I think is the buzzword that's being used out there, as that becomes available, you'll see youngsters able to do their own programming. And
able
you'll
to
see
do their own program.
Yes, able to use objects on the programming screen. Instead of writing the lines of code that you're probably familiar with, the computer lines of words that no one can understand except for a machine. And basically what they'll do is interface and pull icons into place that would say maybe has an accountant module in it. And when you say you want to do an accountant, you hook that up with payroll, and you'll be able to do your programming that easily. There'll be inherent programming in these modules, and all you do is mix and match them with interlocking parts. That will be pretty much for the average day person if they want to do that. The high sophisticated programming will still be done, you know, at the detailed levels. But if we can get them interested now, I think that's important, and I feel that that's probably where a lot of the future is for this country, is being competitive, and I think a lot of that deals in the computers here in the future.
Oh, I know. When our grandson's 6 now, but even when he was 4 and 5, he walked in the door and he'd say, "Grandfather, can I play in the computer?" And he had his programs, and he knew which one, and he got to where he could beat that B or whatever it was.
Right.
I couldn't imagine. And what was the amazing thing? When he started school, he could just read, and I realized he'd learned it on the computer without actually sitting down and, you know, learning to read another way. So he'd learned it from just being exposed to that so many times.
So we see hopefully the thrill and the excitement about computer science obviously is a main proponent of our unmanned either air, ground, or underwater systems. And we're looking at this as a long-term project to hopefully instill incitement into the children so that when they grow up, they'll be interested in pursuing this technology.
Now, I think that we need, rather than being right here in the studio, I'd like us to take us into your world. And if you could, please, I think that you have a clip that tells us a little bit about what you do in your world.
Right. I'll just talk to that real quickly. Mainly what we're doing here is building unmanned ground vehicles, the intent of which is to remote the operator who drives that or flies it from out of harm's way. So, for instance, in the recent conflict that was going on, instead of the individuals being right there and being engaged by the enemy, you would have an unmanned system that had nobody in it that would be engaged or be performing its mission. So if it was destroyed, you wouldn't lose anybody while it's doing that mission. They would be back at a remote control station, which is nothing more than a computer, where they're controlling the object, and then it's sent through radio waves or fiber optics to that remote platform. So that's mainly what our project is about, is trying to get that technology into the defense forces here, so we can use force multiplication, we can cover more fronts with less people, and we also take that soldier that is very precious to us all out of harm's way, and that's what we're about.
Well, we want to see that, and I hope we have a moment after it's over, because I'd just like to ask a couple more questions to you, so perhaps we'll have a moment, and we're going to go, what are we going to see first?
You're going to see it's mainly a tape that we've put together showing some of the technology that we're working in our project office. I'd like to couch it and say it's probably about 5-year-old technology, and we're looking to take the latest technology and end up with better systems.
Well, let's go and see about the unmanned ground vehicle systems.
Okay.
The Unmanned Ground Vehicle Joint Project Office was formed to manage development efforts to field an unmanned ground vehicle system. 3 unmanned vehicles, 2 ground and 1 air, will be shown. They complement each other in an offensive scenario, much as the manned air-ground team. The first UGV is the Tele-Operated Vehicle, or TOV. The system includes 2 Humvee vehicles, a remote vehicle, and a control van. This UGV is the Tele-Operated Mobile All-Purpose Platform, or TMAP. Its operators can be located in fighting holes with a manned portable control unit. We will also use the very low-cost UAV pointer, which can provide the ground commander with real-time tactical intelligence for very close-in reconnaissance. Each of the vehicle's capabilities will be shown in a combat scenario. This also allows a glimpse of the enhanced capability offered by the integration of more than one system. Troops have landed to the north to capture a key enemy radar jamming site and to set up a blocking position for Marine Expeditionary Unit. The MEB is attacking towards its objective. To accomplish his mission of detecting and destroying enemy forces in the area, the Marine Battalion Commander has decided to use both UGV and UAV for reconnaissance and surveillance. He will use pointer to survey all enemy activity. The TOV will be used for route reconnaissance along the axis of advance for the attacking Marines. The battalion commander orders the TMAP to screen the right flank, providing reconnaissance near the large open area just to the north. Both types of vehicles have distinct strengths. UAVs can move more rapidly over large land areas to see the big picture of the battlefield. Hence, they can see the enemy's disposition and can provide battlefield damage assessment. Some UAVs also have night capabilities. Endurance limitations may prevent UAVs from being able to spend much time conducting surveillance. Weather conditions such as rain, fog, sandstorms, or strong winds could also prevent UAVs from being employed. UGVs fill that gap because they have an on-station capability to stay in one place and conduct surveillance in all weather conditions for up to 3 days. Their video zoom capability helps discriminate between friendly and enemy troops. Audio detectors are able to hear enemy movements that might be camouflaged from the UAVs. Lasers can be used to locate enemy positions with rangefinders and designate for smart munitions to ensure a high first hit probability. UGVs are capable of remotely firing machine guns and missiles at enemy targets and are able to detect NBC contaminants. TMAP is screening the right flank of the Marine attack. Audio sensors pick up possible enemy-tracked vehicles. Due to a thick tree line immediately to its front, however, TVAP is unable to confirm enemy activity and requests aid from the UAVs and other UGVs. The battalion commander employs the UAV to confirm the sighting and find a good route to an observation point for the TOV. The TOV is then directed to move forward to an observation point and confirm the possible enemy activity. The UAV checks the TOV route for obstacles or possible ambushes. The UAV found a good spot for TOV and directed it along the best route. After TOV moves onto the tank trail, it hits a chemical mine. An alarm goes off and an NBC-1 report is initiated.
Flash, flash, NBC-1 report. Line 1, 7908, 664. Line 2, 1330.
After the report is sent, the TOV pans the area ahead for more booby traps. Then moves on. This highlights a valuable battlefield capability of unmanned vehicles, the ability to operate in an NBC environment. Now in position, both the pointer and the TOV have confirmed an enemy presence. Using its laser rangefinder, the TOV can determine the exact position and bring supporting fires to bear upon the enemy. These can include air, naval gunfire, and artillery fires, and can also include laser-designated munitions. The TOV operator, already trained as an artillery forward observer, calls in artillery fire.
Big shot, this is ground pounder. Fire for effect, over.
Using onboard navigation in combination with a laser rangefinder, the operator can get precise direction and distance to the target. Information of this type allows a first-round on-target capability and fire-for-effect missions without first adjusting fires. The enemy has decided to use smoke to cover his withdrawal. Meanwhile, the pointer, with his capability to fly beyond the obscurance, calls in the battle damage assessment. The UGVs are used to assess battlefield damage from a different perspective. The capability to work in tandem like this greatly assists the ground commander's control and distribution of fires, particularly when the battlefield becomes obscure through dust, fire, and smoke. In addition, pointer may be used to follow the enemy's retreat. This allows the ground commander to shift his forces in sufficient numbers to meet the enemy threat or to pursue the enemy by maneuver or supporting arms. As the UAV follows the retreat of the enemy, both UGVs remain in position to observe the battlefield. This continuous surveillance capability allows the battalion commander to look for a re-emergence of enemy troops. The battalion commander may choose to relocate his UGVs at this time, depending upon the enemy threat. Relocation of UGV assets could safely be accomplished by leapfrogging the UGVs, thereby continuing mutual support. Or the UAV could select a tentative site and perform route reconnaissance and aerial observation for the UGVs. In any case, the decisions are based upon immediate, real-time intelligence, not information several hours old. You have seen the high mobility that UGVs possess as they screened the right flank and rapidly supported each other during calls for supporting fires. You have seen large amounts of real-time intelligence provided during the battle damage assessment. You have seen the NBC capability of UGVs and how they can be used as a force multiplier. Finally, you can see how UGVs and UAVs can complement each other to locate, fix, and destroy the enemy through reconnaissance, surveillance, and target acquisition, much as the air-ground team of manned systems do with the unique strengths of each exploited. The addition of these systems to the arsenal of the combat leader provide a quantum leap in battlefield control to the force commander.
You can see from that clip that Dr. Jeff Cerny who is Deputy Project Manager for
Right.
the Unmanned Ground
Vehicle
Vehicle
Office.
Office. That,
We make those long names so you can't remember them all. That's how that
that's
works.
and you work with, I have to throw this in for my husband, a Marine
I work
Lieutenant
with
Colonel.
a Marine Lieutenant Colonel by the name of Bob Harper, who's the project manager.
So together, and the whole office is working toward the future of getting this. Now, if we could work as much in our life fighting the enemy, the spiritual enemy, that would be great. To bring you go to Whitesburg, don't you?
Yes, I do.
How do you see science and the belief, since you are a Christian, merging together? Because so many times scientists and engineers didn't really believe in God, you know, and I think it's exciting to see that someone that's over this project, that's deputy director of the project, believes in God. So,
Right. Well, I think science is an instrumental part in our lives, and I think it's important that we know how that works, but all that's for one purpose, and I think we all know that.
That's good. That's
Right.
good. So you're bringing your children you came down from Virginia. How long have you been here?
I'm here for 2 years this time. We were here in the early 80s, left, went up and tried our time up in the Washington, D.C. area, and then decided we wanted to come back down to Huntsville to raise our children. And that was when we had 3 children. Since we got back down here, we now have 4 children. So every time we move, we end up picking up another child. So I'm sure we're not going to move anymore. We're going to stay put.
Stay in Huntsville.
Right.
Well, that's a compliment to Huntsville and the Tennessee
Right.
Valley area that you chose to be here and raise your family here. That's great. What about your the future of your project? Why don't you summarize what we have just seen, both what's happening with CNN, that CNN
Right.
showed, and what you're doing in your particular office?
I think I'll start backwards. Our project hopefully will be going into production before the turn of the century. And what you saw was older technology. We'd like to have more current technology out there, and we want the best for our troops in defending the nation, and that's our objective on that. The objective with respect to the robot challenge is that we're having a pilot test, as we alluded to, between Hazel Green and Challenger, and we want that to see how that pans out, what we learn, what we need to readjust. Then our plans are, if the schools think it went well, and if we think it went well, we'd like to expand that next year to the whole Tennessee Valley and get some industry involved in that, and mainly just get the whole area excited about science and unmanned systems, and see where we can bring the Valley up forward and continue to bring its notoriety throughout the United States.
And the roll-off from that is that our youth have something to really sink their teeth into,
Right.
which is the future of not only the space program, but everything that happens in our
Right.
world.
I think I heard one of the counselors telling one of the students, either an 8th or 9th grader, that the reason they should probably be interested in this is that when they're applying for college, they could say that they actually have done a project, a science project, hands-on with computer science, and may help them get into college. Don't know.
Absolutely. Dr. Jeff Cerny, who is the Deputy Director of the Unmanned Ground Space Vehicle Project, and wait a minute, I'm getting too many words into it now.
Unmanned Ground Office.
Okay, that's short.
Right.
And it's so exciting. I know that you will want to stay in tune with what is happening in that project, and if you're in Challenger or Hazel Green, hey, we want to come over and see, where will it be? Where will the competition take place?
We're trying to find a location to have that, and we're looking at the competition being in March, and we'll put that out once we can find a place to conduct it.
Thank you for being
Thank
with
you.
us today.
Right.
And thank you for watching Vision Plus. If you have any questions, I'm sure that we can help you get in touch with Dr. Jeff Cerny. I'm Bonnie Libhart. Bless your heart for watching Vision Plus.